So in this one it says that the two blocks are being pushed across a surface with an external force F, as shown in the figure at right, well it's down here. The mass M2 of block 2 is greater than the mass M1 of block 1. The blocks begin at rest. The surface is smooth enough that frictional forces can be neglected. So don't worry about friction at all. And even though they don't say this, I'm going to sort of almost treat it like mass 2 is twice the value of mass 1 there. So the first thing they want is some free body diagrams. So let's do that. So here's one for mass 1, here's one for mass 2. So I'm just going to go ahead and draw mass 1. It's obviously got a force of gravity on it. So I'm going to do 1, 2, 3, 4, just randomly there. And I'm going to call this FG1. Well, over here, we also got a force of gravity. I'm going to go ahead and do this. It's got to be 1, 2, 3, 4, 5, 6, 7. Whoops. Well, I'm going to make it double, so I'm going to imagine one more than that. I'm going to call this force of gravity on 2. So again, they don't tell us that it's twice as big. I'm just going to make that assumption. But you'd have to draw it bigger than this one because they did say that that mass is bigger than that one. So this force has to be drawn bigger than that one. Neither one of these blocks is moving in the vertical direction, so they must be balanced the other way. So 1, 2, 3, 4, up. I'm going to call this normal force on 1. And then here I'm going to draw 1, 2, 3, 4, 5, 6, 7, 8. Oh, actually it is 8. So call that normal force on 2. Now block 1 has one more force on it. It's the push. We don't know how big it is, so I'm just going to draw it 1, 2, 3, 4. I'm going to call this force A for force applied. So that's acting on this block. What moves this block forward? He says he slides them both across. There's no friction, so they're both going to start to move to the right there. So what is the force then on this one? What moves it forward? Well, block 1 pushes on block 2. So it's not the guy right here. So I'm going to draw it like this. 1, 2, 3. And I'm going to call this the force of 1 on 2. So block 1 pushes on block 2, and that's what moves it forward. Now, if block 1 pushes on block 2, then we know by Newton's third law that block 2 must push back on block 1. So how hard? Well, equal and opposite. So if this one is a force of 1, 2, 3, 4, did I make it? 1, 2, 3. So this one, 1, 2, 3, backwards the other way. This one I'll call the force of 2 on 1. So 1 pushes on 2 and 2 pushes on 1 with an equal but opposite force there. And as long as this thing has a net force in the x, so I thought ahead and realized I have to draw this force applied bigger than I draw this one. And this one should be smaller because it's just accelerating that M2, but this force is actually pushing all the mass. So it's actually pushing M1 and M2 there. So next thing is one of these where they give you, it's sort of the reverse of what we practiced with 1 or 2C, is they are going to give us the statements and we give them the equations this time. So they say the sum of the external forces on the system will be equal to the mass of the system times the acceleration of the system. That's just Newton's second law, but they've specified it for the x direction there. The net external force, they say we got to fill this in, is just the horizontal push. So by the way, we're doing this just on block 1. So if we look here then, so the sum of the forces is just, we'll call it force applied, is equal to mass times the acceleration. The mass of the system is the sum of the two masses there. So this force actually accelerates both the masses. So now let me actually fill in. The applied force accelerates. This mass is generic. So we want to call it mass 1 plus mass 2. That makes it specific for this problem. Times the acceleration in the x. So the acceleration of the system is then, let's solve for it. The acceleration of the system is equal to the applied force over the combined mass of the two there. And since mass 2 will have the same acceleration as the system, that's both of them together, then the acceleration of mass 2 is the same. So the acceleration of 2 will also be the applied force over mass 1 plus mass 2, like that. The last part here is they say, what if we add a third block? So block 3 of mass M3, that's right here, is added to the system as shown it right. The 3 boxes are pushed across the same surface with the same external force as before. So indicate whether the magnitude of the acceleration of block 2 is now smaller or the same as the original, larger, smaller, or the same as the original situation. Justify your answer. Well, we're still basically doing this situation here. The difference is now that force is accelerating more mass. So it's not going to be accelerating just mass 1 and mass 2. It's going to be that force divided by all 3 masses there. So that means more mass, less acceleration. The system's going to have less acceleration, and therefore block 2, which is part of that system, will have less acceleration.